The last learning target in this unit, we're going to talk about how all the three forms we've worked with can come together to be useful without a calculator. Okay, I think a lot of us in this learning target, from what I've seen, you guys have just been using your graphing calculators to just graph everything and then work backwards. So this learning target, I want us to be able to explore these forms without depending on the calculators. Okay, so we've got three different forms here. We've got vertex, standard, and intercept form, which also is what I called factored form. Okay, so the same thing, factored form, intercept form mean the same thing. Okay, P and Q still mean R1 and R2. They still mean the roots, okay? So that means the same thing. So let's take a look at vertex form first. What are the benefits of vertex form? I think that's pretty obvious. The benefit is that you can find the vertex. Right? And that vertex is just H comma K. It's this number, change the sign. This number, keep the sign. Okay? Standard form, the benefit is this right here. That very last constant value C. C is that y-intercept. Always. Oops. Y-intercept. Okay? So, factored form then. Factored form shows the x-intercepts. Okay? And we've talked about that in all of our learning targets, how each of these does. The other thing we have in every single one of these forms is we have this letter A. A is always that number that is in front of each form. With that said, A, in fact, let me put this somewhere else. A shows concave up or down, right? If it's negative, it's concave down. If it's positive, it's concave up. And it shows stretch and shrink. Okay? And that's true for every single one of these forms. All right? So without calculators, we're going to take a look at these functions, right? I'm going to tell you that all three of these equations right here, all three of them are the exact same equation, just in their own form. Okay? For example, and you don't have to write this down, I'm just going to show it to you. If I take this form right here and multiply it out, again, don't write this down, I'm just showing you, I'd get x squared minus 5x, x and negative 5. Well, when I combine like terms, I get x squared minus 4x minus 5, and you see how that's the same as this one? So all three of these forms are equivalent to each other. They're just written in each of the different versions, okay? So this first one is written in vertex form, okay? So I can find my vertex in this form. My vertex is going to be positive 2, negative 9. I know that because this number and this number. That's my vertex, okay? From the second form, okay, I know the y-intercept, that negative 5. So my y-intercept is going to be at 0, negative 5. And then finally, in the last form, I know my x-intercepts. This was the last learning target you just did. So my x-intercepts are going to be positive 5, 0. Remember, we have to change the sign. And negative 1, 0. So now I've got a lot of points I can plot, right? And I didn't have to use my calculator at all to plot a bunch of these. So I'm going to go ahead and take these points here, and I'm going to go ahead and plot them. So the first thing I'm going to plot is my vertex way up here. So that's 2, negative 9. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's where 2, negative 9 is. Now I'm going to go ahead and plot my y-intercept at 0, negative 5. So 0, 1, 2, 3, 4, 5. Alright, and then I'm going to go ahead and plot my x-intercepts, 5, 0, and negative 1, 0. So 1, 2, 3, 4, 5, and negative 1. Now this isn't 5 points, right? It's only 4, so I need to get one more. To do that, I'm going to draw in my axis of symmetry, which is right here through the vertex. And remember that cool thing I mentioned a long time ago about how these points are equal distance? So see how this is 1, 2, 3 to the left and 1, 2, 3 to the right, and they're equal? So if this green point is 2 away, then I'm going to have a matching green point right here at 2 over. This is why the axis of symmetry is so nice, because it will always be this pattern. And now without my calculator, without finding that table and plugging it in and making a chart, I've graphed this parabola using all three forms. Okay, which I think is actually very cool. You get a lot of really awesome information from these three forms without having to really do any math. Okay, what I'd like you to be able to do on your own is very similar to what I just did. Okay, look at some properties of the equation and try and figure out what the graph might look like without your calculators. So what I've decided to do for you guys is I've decided to give you some equations, and I've decided to give you some graphs, and your practice is going to look very similar to this, okay? And I want you to be able to match what equation goes with what graph, and notice how none of the graph have numbers on it, okay? They're just the basic shapes. So we're going to use some reasoning skills to try and figure this out. And when I say reasoning, I mean using logic. Making sense of some things with what you know. So let's take a look at the first equation. That's in standard form. There are two things I get from the first equation. I get that it's concave down, and the y-intercept is 0, 5. I see two graphs that are concave down. I see this one, and I see this one. So that takes care of the first thing. Now, which one has a y-intercept of 0, 5? Well, this guy has a point already plotted at 0, 5, so it might be B, but I could also argue that that might also be at 0, 5. So I'm going to wait on number 1, because I know it's either A or B, but I might get some more information later that helps me narrow this down. Okay, so let's go to number 2. I'm going to hold off on that one a little bit. Number 2, this is vertex form, and I know that it's concave up. So this is concave up. And its vertex is at 3, 1. Okay, so I'm going to go look at my 4 concave up graphs and see which one has a vertex at 3, 1. So it can't be C. It can't be this one because that vertex is at a negative. There's like, I have to go to the left first, so it can't be C for that, for the green one, number 2. D, this could definitely be at 3, 1, so it might be D. That's definitely an option. E, that vertex is not at 3, 1. It doesn't go up 1. And F, that's definitely not 3, 1. That goes over to the right and then down. So that means that for number 2, that my answer choice is D. That's the only one that logically matches is D. Okay? All right, let's keep going. How about number 3? That's in standard form. I know that it's concave up. I know that its y-intercept is 0, -3. So I'm going to look at my graphs that I have left. It can't be E because that intercept is at positive something. It could be C. I've got that point right there, and it could possibly be F. So that is going to be either F here, or it's going to be C. I'm going to come back to that. Maybe I'll be able to narrow that down later. Letter number 4. This one is in vertex form. I know that it's also concave up. And I know the vertex, this is like having a +0 on the end. So my vertex is going to be 3, 0. I changed the sign. So now I'm going to look at which graphs have 3, 0. So this graph could be it. That could be 3, 0. That's definitely an option. This can't be one down here, this one right here, because the vertex is down. And I don't see any other ones that have a vertex at 3, 0. None of them are sitting on 0 on the x-axis, so I know that number 4 has to be letter E. Number 5 is in factored form, and it is concave up. So I'm only going to look at the graphs that go up. And I've got roots at -5, 0, and 2, 0. So I'm going to ignore A and B because it can't be A or B because those are concave down. And then when I look at the one that here, when I look at C and when I look at F, I'm going to re-put those little blue guys somewhere else because we know those are the blue options here. When I look at C and F, I have to ask myself which one has a root at -5 and 2 and which one doesn't. So C looks like that could be -5 and 2. F does not look like -5 and 2. These are the two roots, right? Does that look like -5 and +2? No way. That should be way farther away and this should be closer. So it definitely has to be C. So this has to be C. Okay? Now that leaves me with this F over here was our other blue option. So now that C is done, I can erase this option from blue. And now I know that F has to go with number 3. Because that was the only one left. Okay? That's how we're using some reasoning skills, right? We're trying to think about what might work and then eliminating options that suddenly another one takes it. Okay? We're reasoning through. Alright, so now we know that 6 and 1 are going to belong to those top two graphs. So let's see what we can get from number 6. And I don't have other colors, so we're going to use this pink color. Okay, so I know number 6 is going to be concave down. Whoa, this pen does a weird thing. Alright, let's pick a different color here, guys. Alright, I've got a dark orange color. Alright, this one is, oh my gosh, this pen. Okay, I want the regular pen, and I would like to use a different color. Let's try that. Let's see if that works now. Okay, we're going to try this rusty orange color without the weird letters. Alright, let's try this again. There we go. Okay, this is concave down. And I've got roots at -2, 0, and I've got roots at +5, 0. When we take out the roots, we change the sign. Okay, so let's go back up. Okay, which one has roots at -2, +5? Well, this one could be -2, +5. And B, that doesn't look like -2, +5. That looks like -5, +2. So this definitely has to be the right one. So that means that number 6 goes with A. And that means that all the way back at the top, that first one that we couldn't narrow down has to be with B, right? There's the y-intercept at 0, 5 right here for B. Okay, so I had to use some reasoning skills. And notice I did not use my calculator this entire time. I didn't need to. The equations gave me everything I had. I did not need to use my calculator. So when you guys get to your practice, you're going to notice that you're going to have a bunch of different things to match. You're going to have 9 standard form equations, 9 vertex form, 9 intercept forms, and you're going to match them to their graphs and the descriptions of them. There's lots of ways to go about doing it and figuring out with some reasoning, okay? Your mastery is going to be very similar. I'm also going to ask you to match with your mastery. So this is something I need you to be able to do, especially because I probably will take your calculator away from you when you do this mastery. So if you go ahead and do the practice and bank on your calculator, you're not going to do so hot on your mastery either. Okay? So make sure you're working hard and asking questions, and let me know if you need any help.